Hello everyone, welcome back to the Math UM8 class, week number 21. Today we will continue the chapter of measurements with the topic of volume. The volume is the measurement that tells us how much the space is one object occupying and how big it is, its size in general, in the three-dimensional space. And today we will focus on some basic fundamental solids that can easily calculate the volume. First, I want to introduce to you the concept of solids of uniform cross-section. Uniform cross-section. Now, let's take this triangular prism as an example. When we cut, imagine that we want to cut it. We use a knife and cut it vertically, and the slice is parallel to the front face of the triangular prism. Then, wherever we cut it, we will still have the same cross section. It is the surface of the face that we cut through. Can you imagine that? So that surface of the surface that the knife goes through is called the cross section. And because the cross section is the same in all the way in whenever we cut it, as long as the cut is parallel to the front face, so this solid is called the uniform cross section. You can see that if we cut it in the middle of the prism or closer to one end of the prism, we still have the triangular cross section. So the cross section is the same whenever we cut it, as long as the cut is parallel to the front face. I hope that you get the idea of the solids of uniform cross section. Some examples will help you to understand it more thoroughly. A cylinder is also a solid of uniform cross section because if we cut the cylinder horizontally, then all the cross section will be the same circle. Can you imagine that? If we cut it in half horizontally, then the new surface created by the cut will be the same circle as the base. Similarly, if we cut the cuboid by a cut that is parallel to one face of the cuboid, then the new surface created by the cut is still the same rectangle as the face. So the cylinder and the cuboid are all both solids of uniform cross section. Now we will come to the volume of solids of uniform cross section. The volume will be equal to the area of the cross section multiplied by the length of the other dimension. Let's consider the cylinder as an example here. You can consider the cylinder as a pile of discs. We put the discs all together, they pile up to make a cylinder. Again, I want you to see the animation. We put many discs to pile up, and they will make a cylinder. Okay. And in order to calculate the volume, we'll measure the volume of a disc and multiply by the number of discs we have. But we imagine that the disc is so small that the height is too small to be considered. So the volume of the disc is very close to the area of the disc. So we need to calculate the area of the disc multiplied by the length. In this case, the length measures how many discs. The length measures how many discs you have. So again, the volume of the solid of uniform cross section is equal to the area of the cross section multiplied by the length. And we have some special cases when we have the formula. Here we have a cylinder, of course. The volume of the cylinder will be equal to the base multiplied by the height, and the area of the base is equal to PR squared multiplied by the height we have. The volume is pi r squared 8. Apply this formula to calculate this cylinder on the right. You will have the volume V is equal to pi 8 squared multiplied by 12 equals 768 pi cube squared. Sorry, cube centimeters. You get the idea? And another special case is the cuboid. The volume of a cuboid is calculated as the base times the height. In this case, the base is the cross-section, and the base is measured by the length multiplied by the width. So we have the volume of the cuboid is the length times the width times the height. And consider this cuboid, for example. We have the volume is equal to 2 times 3 times 4 equals to 24 cube centimeters. The third example is a solid of uniform cross-section, but in this case the cross-section is a weird shape, an unusual shape, but still we know the area of the cross-section already, so things are not so difficult. Can you apply the formula to calculate this? Okay, let's see the answer now. The volume is equal to the cross-section multiplied by the length, and that should be equal to 74 times 6, 74.6 multiplied by 5, and that is equal to 373 cube centimeters. Now we come to the practice section. The problem number 1. Calculate the volume of the following solid. Okay, I suggest you pause the video for 3 minutes and come back to this to see the answer. Have you got the answer? Okay, the first step is to determine the cross section. Of course, if we cut the prism in a cut that is parallel to the triangular face, it will be a triangular face cross section. So the cross section is a right triangle of the measurements of two legs, 13.8 centimeters and 8.6 centimeters. So the area of the cross section is 13.8 multiplied by 8.6 divided by 2 equals 59 times 59.34 square centimeters. And the volume of the solid will be equal to the area of the cross section multiplied by the length. In this case, it is 59.34 times 12.9 equals 765.486 cubic centimeters. That is the answer for this. Have you got all the correct answers? Good. Now moving on to the problem number 2. Calculate the volume of the following solid. Again, we need to determine the cross section. You can see that the cross section is a sector of a circle. This sector is of 280 degrees and the radius of 80 centimeters. So first, let's calculate the area of the cross section. It is pi 80 squared multiplied by 280 divided by 360, and it is approximately 4,978 pi square centimeters. The next step is to calculate the solid volume by multiplying the area of the cross-section by the length of the solid, which is 2 meters. But first we need to convert 2 meters into 200 centimeters. And we have the calculation here. 4,978 multiplied by 200 equals 995,600 pi cubic centimeters. I hope that you all got the correct answers. Good. Now moving on to the problem number 3. Calculate the volume of the following solid. Again, the cross-section of this solid is like a staircase. It is unusual and we do not have a formula for it. We also do not know the area in advance, so we need to work out the area of that cross-section. Again, pause the video for, I think you need 5 to 10 minutes to think about this problem. After that, come back to see the answer. Okay, have you got the answer? Let's check it. The first thing to be noticed here is that it can be implied that each small segment is 300 millimeters, because the 900 millimeters is divided into 3 equal segments like this. So each segment is 300 millimeters. And you can see the symbol for equivalent between the segments here. You can imply that the 3 segments, the 3 vertical segments, are also 300 millimeters. Okay, now we know the measurements. Now we divide the cross section into squares like in the diagram here. We divide it into 6 equal squares. Each square measures the side of 300 millimeters. I want to convert the units to more simple meters. So we have 300 millimeters is equal to 0.3 meters. 1,200 millimeters is equal to 1.2 meters. And the area of the cross section is, we take the area of one square, which is 0.3 squared times 6 equals 0.54 square meters. That is the area of the cross section. And now, in order to find the volume of this solid, we take 0.54 times 1.2 equals 0.648 cubic meters. And that is the final answer. So you get the idea is that in some problems, or most problems, you need to work out the area of this cross section by dividing it or by some tricks. Now let's move on to the question number 4. Calculate the volume of the concrete needed to build this pipe. Here we have a pipe of 1 meter in diameter and 0.05 meter thick and 2.5 meter long. We need to calculate the volume of this pipe. Notice that we have an empty space, an empty cylinder inside the pipe, the space for the water to flow over. Okay, spend like 5 to 10 minutes for this problem before coming back to check the answer. Alright, have you got the answer? I hope you do. Um, the first step is to calculate the radius. The radius of the external circle is 1.5 meters because the diameter is 1 meter. So the radius of the external, the big circle, the outer circle is 0.5. And the thickness is 0.05 meters, so we calculate the area of the internal circle. The area of the internal circle is 0.45 meters. And the area of the cross section is equal to the area of the external circle minus the area of the internal circle. I hope you can see that. Agree on that? It is equal to pi 0.5 squared minus pi 0.45 squared equals 0.0475 pi. And the volume of the pipe concrete is equal to the area of the cross section multiplied by 2.5 meter, and it is 0.0 sorry it is 0.475 times 2.5, and that is equal to 0.11875 pi cubic meters. Alright, I hope I did the calculation correctly. If you don't think so, please leave it in the comment and I'll spot out my mistake. I'm happy to correct it. Alright, if you found a different answer or you didn't know how to solve it, then copy this solution down. Okay, and that is also the end of the lesson today. I hope you enjoy it. I think the lesson today is very practical. You can apply it in a lot of situations in real life. At home, I hope you can spend some time reviewing the lesson, learn by heart the formulae for the volume of cylinder, cuboid, and prism. And we have a small task here to find some object of uniform cross-section in your house and calculate its volume. Okay, thanks for watching the video. See you next week. Bye.